All right, okay, my people. Today I want to talk to you about how to use LLM judges and AI agents at scale, how to process millions of documents without breaking the bank. Hugo Bown Anderson here from Vanishing Gradients. This is based on an hour-long podcast I did with Shreya Shankar from UC Berkeley, whose research in human-centered data management is being deployed at companies like Meta and LangChain. Shreya told me about a database of current police misconduct reports in California that it would take humans over 35 years to build. Now, California is now spending $10 million to see if LLMs can do it instead. This is a perfect example of a prevalent tension in modern AI development. In high-stakes domains, one mistake can undermine the entire system. In low-stakes settings like customer support, pretty aligned can be good enough. The core challenge is finding the most accurate pipeline, then the cheapest way to execute it. Shreya said to me, I see this as a really big search problem. If a user has a query and a document collection, first you want to search for the most accurate pipeline, and then you want to search for how you can swap in models of those pipelines with cheaper implementations. So the takeaway is the goal is not just to build a pipeline, but to find an optimal one within a vast search space of models, prompts, and processing strategies, guided by specific accuracy and budget constraints. So how does Shreya think about this? To manage the complexity and flakiness of LLMs, Shreya's research project, DocETL, treats unstructured data processing like a traditional ETL pipeline, where you have a map operation, where she applies a function to each document. So an LLM-powered map operation could extract themes and corresponding quotes from individual customer support transcripts. Then a reduce operation, which aggregates the outputs from the map phase. By framing LLM workflows in the familiar language of data engineering, MapReduce ETL, you can apply structured thinking and establish principles to new and often unpredictable domains. Now, remember that agents cannot read your mind, so what you need to do is manual error analysis. Shreya asked me, how does the agent know that you expect consistency in outputs? They might have their own definitions of what's correct. So what you need to do, you need to run the pipeline on a sample of documents, perform open coding. That's manually reviewing 50 to 100 input-output pairs, writing free-form notes on any observed failure modes, and continue until saturation. Then you improve the pipeline and repeat. The takeaway here is human-led error analysis is not a chore to be automated away. It's the primary mechanism for aligning the system's behavior with the developer's intent. So what are we using agents for? Shreya's approach to agents is pragmatic and scoped. Instead of building open-ended agents that try to do the task, she uses them as an automated query optimizer, okay? So the agent operates within a structured environment, a goal to optimize a clear metric, for example, accuracy, and with tools, a defined set of rewrite directives or structured rules for transforming pipelines. The takeaway here is that use agents for well-defined optimization tasks where they can explore a solution space and be guided by clear evaluation metrics. Now, when it comes to your LLM as a judge, stop asking, is this good? For accuracy, use a rubric and use pairwise comparison. For cost optimization, first use the cheapest model possible. Limit your output tokens and leverage prefix caching. The takeaway here is that effective LLM-based evaluation requires moving from open-ended questions such as is this good to structured, constrained comparisons against a clear rubric. This improves both the quality of the evaluation and its cost efficiency. Key takeaways overall. Frame LLM workflows as ETL. Use familiar data engineering concepts like map and reduce to structure complex LLM pipelines for better reliability and management. Then, manual error analysis is mandatory. Before scaling, you must manually inspect outputs to understand your failure modes. An agent cannot read your mind to understand your full requirements. 3. Use agents for optimization, not magic. Deploy agents in a scoped role as pipeline optimizers that rewrite code based on concrete evaluation metrics, not as open-ended problem solvers. 4. Structure your evals. For reliable LLM-as-Judge results, use domain-specific rubrics and pairwise comparisons rather than simple scoring. 5. Optimize evaluation costs. Minimize LLM-as-a-Judge costs by using cheap models, limiting output tokens, and leveraging prefix caching. What's the big takeaway? Building AI applications that are both accurate and affordable at scale requires a shift from ad hoc prompting to principled engineering. I've linked to the podcast and a blog post summarizing it in the description. Also, check out our Luma calendar at Vanishing Gradients for upcoming events. And if you enjoyed this, the best way you can support is hit like and subscribe and share it with a friend.